Amazing discoveries keep popping into my inbox, and this one is spectacular. We've all been hoping Betelgeuse will go supernova in our lifetimes. However, the discovery of a little beetle buddy, a tiny companion star tightly orbiting the red giant back in July, unfortunately indicates that Betelgeuse is younger than previously thought and thus probably not as close to going supernova as we had hoped. The tiny Betel buddy is the blue-white dot on the right. And so our hopes stay pinned on Eta Carina. But a more detailed news report of the earliest and best ever capture of a star going supernova was released on November 14th. This is an artist rendition of SN2024ggi. For the first time, scientists determined the shape of a supernova's shock front as it burst through the surface of a dying star. Spotted erupting exceptionally early in April 2024 from 23.6 million light-years away, supernova SN2024ggi briefly displayed an ovoid, olive-like shape before its shock front collided with surrounding material, an observation that fills in some of the blanks about the very earliest stages of supernova evolution. These details would not have been evident if the event had been caught just a day later, highlighting the scientific value of early supernova detection, the agility to mobilize equipment to hone in on the source, and why different observation techniques matter. This photo is the SN2024ggi supernova in the NGC 3621 galaxy. When the supernova explosion was first detected on the night of the 10th of April 2024 local time, Yi Yang, an assistant professor at Tasinghua University in Beijing, China, and the lead author of the new study, had just landed in San Francisco after a long-haul flight. He knew he had to act quickly. 12 hours later, he had sent an observing proposal to ESO, the European Southern Observatory, which after a very quick approval process pointed its VLT, which is Very Large Telescope, in Chile at the supernova on the 11th of April, just 26 hours after the initial detection. I wish it had only been 12 hours, but maybe next time. This is what astronomers have now achieved for the very first time with ESO's VLT. FORST, an instrument on the VLT, uses a technique called spectropolarimetry. Spectropolarimetry delivers information about the geometry of the explosion that other types of observation cannot provide because the angular scales are too tiny, says Leifan Wang, co-author and professor at the Texas A&M University in the U.S., who was a student at ESO at the start of his astronomy career. Even though the exploding star appears as a single point, the polarization of its light carries hidden clues about its geometry, which the team were able to unravel. The ESO is the only facility in the Southern Hemisphere capable of capturing the shape of a supernova using measurements from the FORS2 instrument. With the FORS2 data, the astronomers found that the initial blast of material was shaped like an olive. As the explosion spread outwards and collided with the matter around the star, the shape flattened, but the axis of symmetry of the ejecta remained the same. Quote, "These findings suggest a common physical mechanism that drives the explosion of many massive stars, which manifests a well-defined axial symmetry and acts on large scales," end quote, according to Yang. So an artist's pictorial view to explain this was released on November 6th by the ESO. Look up the video. The 29 seconds are well worth it. Here are a few stills from the video. Another very fascinating space snapshot came my way on Friday. Can you guess what we are looking at? This striking image shows solar magnetic activity in action. Created by combining 9 days of observational data collected by the ESA and NASA Solar Orbiter spacecraft's Extreme Ultraviolet Imager, The image shows the Sun's south pole, which is marked by the white dot, surrounded by bright arcs that show the motion of magnetic structures across its surface. The results contribute to Solar Orbiter's mission to study how magnetic field dynamics at the poles affect the Sun's 11-year activity cycle. As we know, different parts of the Sun move at different speeds as it rotates, which causes its magnetic field lines to become tangled, forming knots and loops. These distortions manifest on the Sun's surface as sunspots, solar flares, and coronal mass ejections. These tangles gifted us the strongest solar flare so far of 2025, an X5, giving us some beautiful auroras this past week. This photo is by Paul. And it caused radio blackouts across Europe and Africa. I know my internet sleuthing was slow and bumpy for a few days, because only a handful of my at least 78 tabs would even open.